So how to find out rule 1? Express each number, that means the given number, as the product of primes. The LCM of 12, 18 and 24 by division method. This is called the division method. Observe here the number ending with 5, it can be divisible easily by prime. 5 is again prime number. How you are going to find out LCM? LCM, all the factors you are going to write and highest power of that number you are going to take it only once. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty, Vidhyaashram, Temple of Excellence Pre-University College, Mysuru. So in the last session, we have learnt about how to find out or how to find the prime factors of the given number and how to write the sum of all positive divisors of that number. And then also we have learnt the canonical representation of a given number. So in this session, we are going to learn least common multiple and the problems on least common multiple. That means you are going to have two rules under least common multiple under that problem. So and then rules to find out, as I told you, LCM and then highest common factor, which is HCF, the examples problems of highest common factor or GCD, and then you are going to have rules to find out HCF, which is especially here rule 1 you are going to study. So let us move on to finding the LCM of a number. Now the least number which is exactly divisible by each one of the given number is called the LCM. Got? So here rules to find out LCM is to find the LCM by first one is prime factorization method. Okay, this is a rule 1. Rule 2 is division method. So how to find out rule 1? Express each number, that means the given number, as the product of primes. Okay, that means you are going to find out the factors of the given number. You need to represent that as product of the prime, that is as canonical representation. That will be is equal to product of highest powers of all the factors. This is very important. Okay, so after writing the canonical representation of each number, you are going to take it as the prime numbers of highest powers only once. That is nothing but the LCM of prime factorization method. Now let us move on to how to find out the problem by prime factorization method. So here I have taken one problem. Find the LCM of 12, 21 and 24. Wow. So here let me take what is 12 can be written as or divisible of 12. So let me write it here. 12, you can have 12 is only the even number. Even prime number will be is equals to 2 6 are 12 again. It will be a even number, 2 3s are 6. Again, it is an odd number or prime number, 3 1s are 3. Therefore, so 12 can be represented as, which will be is equal to 2 twice, 2 squared into 3 1s, correct? Next, you are going to have it as 21. 21 which cannot be divisible by 2 because it is a odd number. Odd number, prime number will be 3. So 3 7s are 21. Again, you are going to have it as 7 is only the prime number which is divisible by 1. So 21 can be written as, see, 3 power 1 into 7 power 1. Next, we are moving on to 24. So 24, 2 1s are 2, 2 2s are 4 because ending with 4 is even number can be divisible by only the even prime number is 2. So again, 12 is an even number, so it can be divisible by 2. 2 6 are 12. Again, 6 is an even number, 2 3s are 6, but 3 is an odd number. And also the prime number which is divisible by only 1. Therefore, 24 can be represented as, what is that? 2, 1, 2, 3. 2 3 times repeated into 3 only 1 time. Dear students, you observe here. So you are going to write all the prime factors which you are having for 12, 21 and 24. Okay, all the prime factors, and that prime number highest power you are going to write it as. So LCM of, you are going to write it like this. LCM of all the three numbers, that is 12, 21, 24 will be is equals to, see, you are going to write all the numbers only one time, that is 2 is there, 3 is there and 7 is there, right? So 2 into 3 into 7. Now you are going to write all that numbers highest power only once. Highest power is what? 2 squared is there, 2 cube is there. Which is highest power among this? 2 cube. So you are going to write 2 power 3. Again 3 is there, 3 highest power in this. Again 3 power 1, here 3 power 1, only 3 power 1. Again 7 is not there here, but here you are having 7 power 1, here you do not have, but you are going to write it that as 7. All the numbers of highest power, that will be and product of that numbers. It is the LCM of the given numbers. Understood? So this you are going to multiply. The answer 2 cube, you are going to have it as 8 into 3 into 7, which will be is equals to 8 3s are 24 into 7. So you are going to have it as 7 4s are 28, 2, 7 2s are 14, 14 plus 2 is 16. So 168 is your LCM of 12, 21 and 24. Okay, next we'll be moving on to the problem. Find the LCM of the given number by factorization method. Okay, so first let me find out what is 8 can be written as. So 2 4s are 8, 2 2s are 4, 2 1s are 2, right? So therefore 8 can be written as 2 power 3, right? Next you are going to have 10, again even number. 2 5s are 10. So 2 5s are 10. 5 is only the prime number which is divisible by 5. 5 1s are 5. So 10 can be written as 2 power 1 into 5 power 1. Next you are going to have it as 12. So 12, 2 6 are 12. Again you are going to have 2 3s are 6. Again 3 1s are 3. So 12 can be written as 2 power 2 into 3 power 1. Right? So you are going to write the LCM of 8, 10, 12, which will be is equals to, first you are going to write all the numbers. All the numbers means 2 is there, 5 is there, 3 is there. 2 into 5 into 3. So 2 is repeated what? Powers, highest power. Highest power is 3. 5 highest power is 1. 3 highest power also 1. So 2 cube is 8 into 5 into 3. So the answer will be, you are going to have 8 5s are 40 into 3. So 3 4s are 12. 120 is the LCM of 8, 10 and 12. Is that so easy? We'll be moving on to the next problem. Find the LCM of the following by prime factorization method. So you are going to have it as 5, 10, 15. Let me find out each. So you are going to have 5 can be written as what? Only one number. 5 1s are 5, which will be 5 power 1. Again you are going to have it as 10. 10 can be divisible by 2. 5 1s are 5. So 10 can be written as 2 power 1 into 5 power 1. Next will be 15. So 15, it is only divisible by 3, either 5. Let me take the 3 number, that is 3 5s are 15. Again 5 1s are 5. So you are going to have 15 can be written as 3 power 1 into 5 power 1, isn't it? Now write down all. So LCM of, you are going to have it as LCM of, what is that? 5, 10, 15. Write all the numbers. 2 into 3 is there, into 5 is there. Write their highest power. Only once. 2 power 1, 3 power 1, 5 power 1, which is 2 into 3 into 5, which will be is equals to 2 3s are 6, 6 5s are 30 is your answer. So the LCM of 5, 10, 15 is nothing but 30. Okay. So next we'll be moving on to find the LCM of the number by factorization method 16, 20 and 24. So let me take out 16 first. So it is even number, even prime number is only 2. So 2 8s are 16 again, 2 4s are 8 again, 2 2s are 4, 2 1s are 2, correct? So therefore 16 can be written as 16 will be is equals to, what is that? 2, 1, 2, 3, 4, 2 power 4. Similarly, we'll be moving on to next 20. Let me find out by factors. 2 1s are 2, 2 zeros are 0, 2 10s are 20. Next, you are going to have it as 2 5s are 10. Next, 5 1s are 5. So, you are going to have 20 can be written as 2 squared into 5, right? Next, we'll be moving on to 24. So, 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 3s are 8, 3 1s are 3. So, therefore, 24 can be written as 2 repeated thrice into 3 only repeated only once. So, you are going to have all the numbers highest power product. So, LCM of 16, 20 and 24 will be is equals to, what is that? 2 into 3 into 5. Let me write down all these highest powers. Highest powers is 2 power 4 into highest power of 3 is only 1. Highest power of 5 is only 1. So, you are going to have it as 2 power 4 is 16 into 3 into 5. Right? So, you are going to have the answer. So, the answer, therefore, 16 into 3, the answer will be is equals to 240. So, therefore, the prime factors of 16, 20 and 24 is nothing but 240, the LCM. Okay. So, next we'll be moving on to rule 2. So, till now we have learned rule 1, which is a factorization method. Now, we'll be moving on to rule 2, which is nothing but division method. Okay. So, write the given number. What is the procedure for this one? Write the given numbers in horizontal line. In a horizontal line means like this. This is a horizontal line. Our numbers will be separated by a comma. If there are 3 numbers, each number is separated by a comma. In a horizontal line, you must write it. Okay. So, and separating them by a commas. Divide by any one of the prime numbers. What are all the prime numbers? We start 2, 3, 5, 7. That's here I have written 2, 3, 5, 7, etc. Any one of the prime number which will be exactly divide at least any 2 numbers. So, in the given 3 numbers or the 4 numbers, you have to choose the number of the prime number which will be exactly divide at least any 2 number. Okay, that's what this procedure of the first point. Write the quotient and undivided numbers. Undivided numbers means, for example, the first and second number is divisible by 2, but the third number is not divisible by 2. That means you are going to write that undivided number as it is. Got? So, this is the undivided number in a line. Below the first line, you are going to have it as. Below the first line, that means next line you are going to have, you are going to write it as. So, repeat the process until we get the numbers which are prime to one another. The last line, until we have to get the numbers as product of numbers will be a prime number. Got? Until that, you need to repeat the process. The product of all divisors and the number of the last line will be the required LCM. So, the last number, when you multiply all that 3 number or the 4 number is given, so that will be the product of all the prime. Now, let me move on to the question, how it will be, how we are going to find out. So, here I have chosen find the LCM of 12, 18 and 24 by which method? You are going to have it as by division method. Okay. So, division method you are going to have it as, see, 12, 18, 24. So, you are going to write the line, horizontal line like this. You are going to choose one number. That number divide at least any 2 of this number. Got? So, therefore, there is the 2 which will divide 12, 18 and also 24. So, let me start with 2 which is a even prime number. So, therefore, you are going to have 2 6 are 12, comma 2 9s are 18, comma, again 2 12s are 24, isn't it? Next again you can choose again 2 because 6 and 12 it can be divided by 2, but 9 cannot be divided by 2. Let me write 9 as it is. 2 3s are 6, comma, 9 as it is, comma, 2 6 are 12, right? Again you are going to write it as, you can choose here, which is the 3 9 6 divisible by what? 3. 2 only divisible by, only it can be multiplied, what is that? 6 it can be divisible by 2, but 9 and 3 cannot be, but 9 and 3 can be divisible by 3. So therefore let me choose that one. 3 1s are 3, 3 3s are 9, 3 2s are 6. Dear students, you can observe here 1, 3 and 2 are prime numbers, correct? So that product you are going to take it as. So otherwise if you are getting confused, you can divide. So you are going to have 2 first, 1 cannot be divisible by 2 as it is, 3 cannot be divisible by 2 as it is, 2 is divisible by 2. Again you are going to have 3. So 1 can be not divisible by as it is, 3 can be divisible by 1. So 1 is again a prime numbers. Until you get 1, you can multiply. So this will be the product of all that you are going to have. So LCM of, what is that? LCM of 12, 18, 24 will be is equals to, what is that? All numbers it will be multiplied. 2 into 2 into 2, correct na? 3 times you are going to have it as. Let me write 2 into 2 into 3 into 2 into 3, correct? So therefore you are going to have 2 2s are 4, 4 3s are 12, 12 2s are 24, 24 3s are, which will be is equals to 72. So the LCM of 12, 18 and 24 by division method, this is called the division method, is 722. Okay. Next we'll be moving on to find the LCM of the following number by division method. What they have given? 48. Let me write that in a horizontal line. 96 and then 72. You can observe, dear students, all the numbers are ending with even number. So it can be divisible by only the even prime 2. So let me take that 2 here. So 2 2s are 4, 2 4s are 8, comma. 2 4s are 8. 1 is getting carry over. 16 it will become 2 8s are 16. Again, you are going to have 2 3s are 6, 1 is getting carry over 12, which is 2 6 are 12. Again, you can observe, dear students, all the numbers is ending with even number which can be divisible by again 2. Again 2 12s are 14, correct? 2 2s are 4, 2 4s are 8. Again 2 1s are 2, 1 is getting carry over 8. 2 8s are 16. Again, you are going to have it as, these are all even number. So even number is divisible by only the even prime. So you are going to have 2 6 are 12, 2 12s are 24, and then 2 9s are 18 or 9 2s are 18. Next you are going to have, see, you can observe 6 and 12 and 9. All that are, these two are divisible by 2. You can choose at least 3 or 2. Let me choose it as 3 only. So 3 2s are 6. 3 4s are 12. Again, you are going to have it as 3 3s are 9. So only that you are going to have it as, but 2 and 3 are even number. Is 4 is a even number? No. So you are going to have it as 2 again. 2 1s are 2, 2 2s are 4. Again 2. It is not divisible by, as it is you are going to write it as, correct? So next, until you get 1, you are going to do it. So 2 again, let me take it as here. 2, 1 it is not divisible as it is, 2 is divisible by 1, 3 as it is. Again, you are going to write it as 3, 1, 1, 1, that's it. So what you are going to write it as? LCM of 48, 96, 72 will be is equal to 2, 1, 2, 3, 4, 5. So 2 to the power of 5 into 1, 2, 3 to the power of 2. 2 to the power of 5 is 32 into 3 squared is 9. What is that product? You are going to have, the answer will be 288. Is that so easy? So the LCM of 48, 96, 72 is 288 by division method. We'll be moving on to the next problem. Find the LCM of the following number by division method. 25, 75 and 150. Let me take this one as, what is that? 25 in the horizontal line, 75. Dear students, observe here the number ending with 5, it can be divisible easily by prime. 5 is again prime number. Let me divide it by 5 here. So you are going to have it as 5, which will be is equal to, what is that? 5 5s are 25. Again 5 1s are 5. You are going to have it as 2 will be the what is that, carrying over, correct? 25 again, 5 5s are 25. Again 5 3s are 15. Again you can observe this is divisible by 5. 5 1s are 5. 5 3s are 15. 5 6 are 30. If you see here, 1 3 are the prime but 6 is not a prime. So again divisible by what? 3. 1 cannot be divisible by 3. You are going to write it as it is. 3 is divisible by 3, correct? 6 is divisible by 2. So if you observe here, 2 1 are prime. So therefore you can write it as here 2 1 comma 1 2 1s are 2. If it is not divided, as it is, undivided number as it is, you are going to write it as. Therefore LCM of 25, 75, comma 150 will be is equals to, what is that? 5 how many times? 5 squared into 3 how many times? 3. 2 how many times? Only 1, which will be is equal to 25 into 3 into 2. So the answer will be 25 2s are 50, 53s are 150. So therefore LCM of 25, 75, 150 is 150. Got? Next we'll be moving on to find the LCM of the number by division method. That is 4, 12, 24. Let me write by horizontal line. So you are going to have all are even number. Even prime can be divided. 2 2s are 4, 2 6s are 12, 2 12s are 24. Next, 2 1s are 2, 2 3s are 6, 2 6 are 12. Again 3. 1 cannot be divided by 3, as it is you are going to write. 3 is divisible by 3, 1. 6 is divisible by 3, which is 2. Again you are going to have 2 is divisible by 1. 1 comma 1 comma 1. That's it, isn't it? So therefore LCM of 4, 12, 24. You are going to have it as 2 thrice it is 1, 2, 3. So 2 power 3 into 3 power 1, which will be is equal to 2 power 3 is 8. 8 into 3, which will be is equals to 24. Correct? This is the LCM by division method of the number 4, 12 and 24. Next we'll be moving on to 3 scales are 65, 85 centimeter, 95 centimeter in a length. What is the length of the cloth that can be measured exact number of times using any one of these 3 scales? So we need to find out the LCM of these 3 number. So therefore I am going to write it as according to by division method or by factorization method. So 65, 85 and then 95, which is divisible by 5. So 5 1s are 5. So you are going to have 5 3s are 15. Again 5 1s are 5. So 35. 5 7s are 35. 5 1s are 5, which is remaining is what? 4. 45 means you are going to have 5 9s are 45. Correct? Again, if you see this one, 13, 17 and 19 are the prime numbers. So therefore, you are going to have it as 13 can be 1, 17, 19. Again, 17, 1, it is not divisible. 17 is divisible. 19 is not divisible. Again, 19, 1, 1, 1. Correct? So therefore, you are going to have LCM of, what is that? That cloth, what is the length? Length they have asked. So the LCM of these. LCM of 65, 85 and then 95 gives you the answer 5 into 13 into 17 into 19. The answer will be 10995. That is your answer. This is the length of the cloth. Okay, you are going to have it as. Next, we'll be moving on to find the number which when divided by 16, 20 and 40 leaves the remainder. Remainder as 2. Okay. So, the answer you are going to have it as, the answer is 20995 is your answer, or that is length of the cloth. So, we'll be moving on to the next is nothing but how to find out the HCF of, that means highest common factor. HCF is also known as greatest common divisor, that is GCD, okay, or you are going to have greatest common measure. All these are naming of HCF, highest common factor. You are going to have greatest common divisor, greatest common measure, okay. So, first you are going to have definition will be an integer D is called as GCD or HCF of two integers if A and B, both of them are not 0. Both of them must be not 0 if D by A and D by B in the form of D by A and D by B, and every common divisor of A and B divides D, okay. That is x by A, x by B is nothing but x by D. If it is a number, I am going to take it as x by A and x by B which is divisible by is equal to, you can write it as x by D. Usually, GCD of A and B is denoted by D is equal to A comma B. This is how you are going to denote the number. So, for example, HCF of 8 and 16 is, what is that? Denoted by A, 16 is equals to 8. I'm going to tell you how to find out that. And HCF of two numbers, unique positive integer. That is, see, HCF of two numbers will be unique, a positive integer. And then if A comma B is equal to D, then D is equal to minus A comma B, which also will be is equal to A comma minus B. One can be a positive and other can be a negative, which will be is equal to minus A comma minus B. And A will be a positive integer. Understood? Next we'll be moving on to rule 1, how to find out the HCF. So first we'll be moving on to the prime factorization method. So here don't confuse in between the LCM and the HCF. HCF is highest common factor. How you are going to find out LCM? LCM, all the factors you are going to write and highest power of that number you are going to take it only once. That is the LCM by prime factorization method. Here, how? Express each number as a product of primes. Same as like here LCM, product of primes you are going to write it. And then HCF will be is equal to product of at least the powers of common factor. That means you are going to check in each number which are all the common numbers. That powers you are going to have it as, see, that least powers. Least means lowest powers of common factors in all. You are going to take it as the HCF of the given numbers. Got? So let me find the HCF of now 12, 15 and otherwise let me take it as this number here only. What is that? Find the HCF of 12, 15 and then 18. Now I am going to do by prime factorization method 12. What is that? You are going to have it as 2, 6 are 12 as usual and then 2, 3s are 6. 3 1s are 3. So 12 can be written as what? 2 power 2 into 3 power 1. Observe here. Okay, next you're going to have 15. 15 can be divisible by 3 5s are 15. You're going to have 5 1s are 5. So 15 can be written as 3 power 1 into 5 power 1. Next you are going to have it as 18. So 18 is divisible by 2 which is an even number. 2 9s are 18, 9 is a odd number which is divisible by 3, 3 3s are 9, again 3 1s are 3. So the 18 can be written as 2 only one time into 3 2 times. Now here you need to observe these are all canonical representation. In the canonical representation you have to take the common factors, common prime factors. See, 2 and 3 is common. Here 3 is common. Here 2 is not common here. Here 2 is common. In all the 3 numbers, 2 must be common. So 2 is not common here. So we cannot take that one. 3 is here, 3 is here, 3 is here. That 3 lowest power you are going to take. Therefore, here I am going to write it as HCF of 12, 15 and then 18 will be is equals to, see, if you see 2 here, 2 is here, 2 is here, but 2 is not here. So therefore, you are not supposed to take that number. Common number, 3 is here, 3 is here, 3 is here. But you need to take lowest power of 3. Which is the lowest power of 3? 3 squared is highest power. 3 power 1 is only the lowest. So therefore, you are going to write 3 power 1, which is common in all. And then you need to check any other number. 5 is here, but 5 is not here. Therefore, 5 cannot be written. So therefore, this is only the number 3 power 1 which gives you 3. So 3 is only the highest common factor of 12, 15 and then 18. Understood this one? Next we'll be moving on to the problem. Still you will be getting how will be the pattern and how we are going to find out by prime factorization. So here by prime factorization, HCF you are going to find out of the given number. Let me find out one below the other prime factors of this. 60 is a even number. So 2 3s are 6. 30 again you are going to have 2 1s are 2. Again carry over will be 1. 2 5s are 10. 15 is divisible by 3, which is a odd number. So you are going to have 3 5s are 15. Again 5 1s are 5. So therefore 60 can be written as 60 will be is equals to what is that? 1 2. 2 power 2 into 3 power 1 into 5 power 1. Correct? Next you are going to have 72. 72 again even number. 2 3s are 6, 1 is getting carry over, 2 6 are 12. Again 36 is a even number, 2 1s are 2, 2 1 is getting carry over, 16, 2 8s are 16. Again 2 you are going to have it as 9s are 18. Again 9 is a odd number which is divisible by 3, 3 3s are 9. Again 3 is a prime number which is can be divisible by only 1. So therefore the factors are canonical representation is 72 is equals to 2 is 3 times repeated 2 power 3 into 3 is 2 times repeated 3 power 2. Correct? Next we'll be moving on to 84. 84 again even number. So 2 4s are 8, 2 2s are 4. Again 2 2s are 4, 2 1s are 2. Again 21 is an odd number which is divisible by only a 3. So 3 7s are 21. Correct? So next you are going to have 7 is a prime number which is divisible by 1. So therefore 84 can be written as 2 into 2 squared. Again 3 is only once into 7 power 1. Correct? So you need to check out HCF of what is that? 60, 72, 60, 72 and then 84. What is that? HCF will be. You need to check in all the numbers which is common. 2 is here, 2 is here, 2 is here. Correct? But you need to write least power of 2. Which is the least power of 2? Here 2 squared, here 2 cube, here 2 squared. Which is the least power in 2 cube and 2 squared? 2 squared. Therefore 2 squared into product of, next again common. 3 is common here. 3 is there here, 3 is there here, 3 is there here. See 3 squared, 3 and 3. So therefore you are going to have lowest power of 3. Among 3 squared and 3 power 1, lowest power is 3 power 1. That you are going to write 3 power 1. Any other number is common? 5 is here, 5 is not here, 5 is not here. So it cannot be written there. 7 not here, 7 not here, but 7 is there. So 7 is not common. So that you are not going to write. So 2 squared is 4. 4 into 3 power 1 is 3. 4 3s are 12. So 12 is the highest common factor of the numbers 16, 72 and then 84. Understood? Next you are going to have it as find the HCF of the following number by prime factorization method. What is that? So 34 by prime factor. 34 is again a even number. So 2 1s are 2. 1 is getting carry over. 2 7s are 14. 17 is what? It is a odd prime number. So therefore 17 ones are 17. So 34 can be written as 2 power 1 into 17 power 1. Correct? 17 2s are 34. So next you are going to have it as 85. 85 is only the number which is divisible by 3 or 5. Let me try with 3. So you are going to have 3 2s are 6. 3 2s are 6, 3 3s are 9. It cannot be because 3 2s are 6 means 25. 25 cannot be divided by 3. Let me try with 5. Ending with 5 is always 5 you can choose. 5 1s are 5. 3 is a carry over. Correct? 35. So 5 7s are 35, isn't it? So next you are going to have it as 17 is a prime number, 17 ones are 7. So 85 can be written as 5 power 1 into 17 power 1. Similarly 153. 153. See, 3 5s are 15. So it can be divisible by 3. 3 1s. 1 cannot be divisible by 3. Carry over 15. 3 5s are 15. 3 1s are 3. Again 51 is divisible by 3 again. 3 1s are 3. 2 is a carry over. So 21. 3 7s are 21. 17 is only the prime number. 17 ones are 71. 17 ones are 17. So 153 can be written as 3 squared into 17 to the power of 1. Right? So now we are going to have it as C highest HCF of what are all the numbers? 34, 85 and then 153 gives you what are all the common numbers? Repeated here, 2 is there, not there, not there. So 2 cannot be written. 17 is there, 17 is there, 17 is there. So which can be written? 17 to the power of 1. Lowest power of 17. Only 17 to the power of 1. Again you are going to have 5 is not there, 5 is there, 5 is not there. 3 is not there, 3 is not there, 3 is there. So therefore HCF of 34, 85 and 153 is only the number 17. I hope you understood this. Next we'll be moving on to find the HCF of the following by prime factorization method, which they have given 165. Let me find out. 165 means which can be divisible by 5, you can take it as, correct? So 5. So 16, we are going to take 1 cannot be divisible by 5. You are going to take carry over, which is 16. 5 3s are 15. 1 is remaining. 5 3s are 15. Again, which is only divisible by 3, correct na? So you are going to have 3 1s are 3, 3 1s are 11. Again, it is divisible by only 1 prime number. 11 1s are 11. So therefore, 165 can be written as, what is that? 5 power 1 into 3 power 1 into 11 power 1. So next you are going to have 225. 225 which is divisible by 5. So 5, 2 cannot be divided. 22 you are going to take it as 5. 4s are 20. Again 2 is a carry over here. 25. So again 5 5s are 25. Again you are going to have 5 9s are 45, correct? Again you can divide it by 3. 3 3s are 9. Again 3 1s are 3. Right? Therefore you can write it as 225 will be is equals to, what is that? 5 squared into 3 squared. Right? So therefore you are going to have it as 5 squared into 3 squared. Let me write HCF of 165 into 225, which will be is equals to, what is that? You are going to have it as common number. 5 is common, 5 is common. That least power, which is 5 power 1. Again 3 is common, 3 is common. From which is lowest power? 3 power 1. 3 power 1. But 11 is not common in both. Therefore 11 cannot be written. So you are going to have 5 3s are 15. That is your HCF of 165 and 225. We'll be moving on to how to find out the HCF of by, what is that? This is a rule 1 we have taught by prime factorization method. Next session we'll be moving on to how it will be the rule 2. So thank you dear students.